Good evening, my lovely viewers. Hello. I am doing the thing where I sincerely hope that you can hear me. But hello and welcome. Welcome again. Welcome for the first time to the Geeky Faye Art SparkFun collaboration live stream series of the SparkFun Inventors Kit. I am so excited to have you all back. Or again, if it's for the first time, hey, welcome. It's okay if you missed the first two. It's all good. You can still go back and watch them if you want. But we're gonna hit kind of like the halfway point. I think we're gonna pass the halfway point of the Inventors Kit today. So like we're doing all right. We're doing crispy. We're doing good stuff. How y'all doing? How y'all doing today? It has been absolutely grim in the UK, down in London, and possibly all over the country. It's been so rainy and terrible. So it is the perfect day for electronics. Absolutely perfect. As you can see, we're back with my my dual camera setup with the lovely macro. I'll let y'all have a preview. Volume's a bit low. Oh. Let's see if I can't get that up a bit. How's that? Is that better? Is that better audio? I realized that maybe I do need to move this a little bit closer. I was trying to be cheeky and have it a little further away. But I'd rather you hear me. All right. Let's see. Let's see if that's better. I realized that by the time y'all actually hear me, by the time I see that you heard me, it'll be like 5 minutes later. You gotta love a stream delay. Better. Wonderful. Awesome. So now we can hear me good and clear. Yes? This is important. Obviously, you got to be able to hear me and understand me. But yes, it has been raining. I was going to show you the wonderful juicy close-ups that y'all can come to expect from my streams. But yeah. So yes, of course, it is raining. It is gross because it's August and it's the UK. 100%, yes. I do apologize if there is a little bit of background noise, as it is still quite warm. And so I have the window open so I have a little fresh air and so I don't melt and die, because that would make for a very different stream. So obviously if the noise gets to be too much, I'll close the window, but it should be fine. And yeah, we're a little bit earlier this time. I thought that since I don't really have a super set scheduled stream time yet, that I would experiment with something a little bit different. So if you prefer this time to the later time, please leave a comment in the actual like video page, not just in the chat, but you can put something in the chat too. That's good. Let me know. Let me know if earlier is better, if later is better, if you're completely indifferent, if you don't exist on this, standard space-time plane, that's fine too. Let me know. It's all good. For those of you who are new, maybe this is your first time joining in, we are going through the SparkFun Inventors Kit, and we are on project 3 this week. Or this month, or however often I do this. And it looks like we're going to be getting into some new and interesting things. I definitely teased a little bit with the sensor, because I can't get over how cool it looks. Like, to me, this really is the coolest thing. All right, this is going to make noise, isn't it? Yeah, you are. Let's, yeah, of course it's chucking it down again right now. I am very glad I'm in here. But yes, the sensor. I love this. This is just the coolest thing. And if you follow me on social media, you will see that I was sharing some photos at the back of this. And I think you can kind of see now just how close I was able to get, because I was able to read the numbers on this, and like, you can't even like, look at how small next to my fingernail these little itty bitty tiny resistors are. It's macro photography is just the coolest. It does not lack googly eyes. Oh, actually, yes, it does lack googly eyes, but I don't have any googly eyes. So we will be working our way through all of Project 3 on stream today. And I hope that if you are new to electronics too, that you're maybe following along at home. If you don't have the kit, you can absolutely get one and join next time, or just do it in your own time. That's cool too. But if you already know lots about electronics and you want to offer help and advice and thoughts and stuff like that, feel free to do so in the chat. Just be polite and be friendly and understand that not everyone knows as much as you do, including me. So it is, it's nice to be nice. I realize I sound like a Disney movie here a little bit, but obviously you can see chat's on the screen. If you are somewhere where you can't actually see the chat window, you can actually see it on the screen. And you may have also noticed that there's a little thing here. Hey, look at that. That is basically my version of the super chat, because I don't have the official YouTube super chat. My Ko-fi is set up to work a little bit like the super chat. So if you make a donation during the stream, it will pop up on screen with your message. I will see it. I can give you a shout out. I can thank you personally for helping to support the channel and the work that I do. So that is a thing. And I imagine one of my lovely mods will link to my Ko-fi in the chat, because I'm realizing I forgot to put a link to it, I think. But yes, so I think that's the run of it. I think that's the gist of it. Did I miss anything? Those of you who are regulars here, and you've been here before, am I missing anything important? Is there anything I should add in? Oh my goodness. So yeah, tonight, this year, 2021, we are going to be doing some stuff with the ultrasonic sensor, but also with the little tiny micro servo. Look at how small it is. Oh my God, I love it. Now, admittedly, even in my lack of prior electronics knowledge, I knew what a servo was. Like, I definitely had heard of a servo. I was aware that, you know, it controls motion, it moves. But this is new to me. This is like completely new. I have a better understanding now than I did a week ago when I first shared the photo of it, as lots of people kind of dropped their own personal projects with their ultrasonic sensors in so on my thread, which was super cool to get to see how other people are using it. But it is still very, very new to me. So it definitely looks like there will be some other familiar things in this. I'm definitely seeing LEDs and potentiometers and stuff, which is good, because I know a little bit about those things already, sort of. I am like partway there with my understanding of this stuff. So yeah, all right. I think I've covered introductions, and yeah, I think it's time to get going, because I think we've got 3. Yeah. three projects or three parts to this project to get through. And the first one is servos, all about servos. I am, oh, it looks like the 3D printing professor has read ahead and is giving spoilers. It's fine. It's not really a spoiler, is it? All right, so let's switch over. Actually, I'll stay here for now. So, yes, obviously we get a nice little introduction to our new components, which for this first part is definitely going to be the servo, the micro servo, that. Now, I had immediately noticed when I was just looking at it before I even started reading that this does have 3 cables. Now, I had definitely become familiar with things having a ground and a power. Like that very much seems standard. This obviously has a third. So I was quite grateful that it mentions in here that there is 3, and one of them is for signal. So I guess like when we connect a jumper cable to provide the signal for like a button or an LED or something, this has one basically built in, it seems, if I'm understanding correctly. Because it says when you send the right signal through the signal wire, the servo will move to a specific angle and stay there. And the signal is sent, the signal that is sent is a PWM signal, which is the same used to control the RGB LED, which that's pretty cool. It actually, this particular servo as well comes with different little mounts. I liked this one, admittedly. This one reminded me of a tiny helicopter, so I was kind of into that. So I was like, I'm gonna put that one on since it doesn't really matter. So my servo is more or less ready, though apparently it needs a little bit of sticky to it to stick it to the board. So I'm gonna put that on, or I'm gonna attempt to put that on, and this is gonna be one of those things where like everything is all fine and then I get messed up on removing, a tape thing, trying to tape something to something like that. It feels typical. It feels like the sort of thing I can see occurring. So, all right, that's part 1. We got 1. That's good. Oh God. And then 15 minutes later, oh no! Oh no! That's not how that's supposed to go. All right. We've already entered the point in the evening where I make weird sounds. How long did it take? 15 minutes. Well done, me. Apologies to any new subscribers, new fans who are like, what the heck is going on? What is up with the weird sounds? But that's what you get at Geeky Faye Art. You get me just basically being my most gooberific self live. There we go. Look at that. Let's clean up after ourselves, shall we? All right, so where am I supposed to put this? This shows it there, but is that really where I want it? Yeah, I guess it is. Okay. Oh no, I'm realizing that it looks like there are some things that I was potentially supposed to kind of get sorted in advance, which I decidedly did not do. So this will be interesting. We will figure it out when we get there, because we're not there yet. So, all right. So it looks like they've got it kind of like so. Heat it. Oh, I think I did it a little too. I guess that works. So y'all can still see it. So you can see the servo. It's important. In fact, actually, if it's not too late, yeah. Let's do it a little further up. This is actually very cool. This is very cool stuff. This is this double grip stuff. Look at that. All right. Yeah. Yeah. So I do love we're getting a little bit of auxiliary education here today. The 3D printing professor, who obviously is qualified as a professor, says that servos are amazing things. They're basically blind motors hooked up through gears to a potentiometer to sense how much is turned and additional circuitry to read the signal, react accordingly. Cool. I like that. That's awesome. Yeah, I have heard that servos are pretty cheap, so this is good news for me in future projects that require servos. So I'm gonna go back a little bit. So back to the type. So this thing, again, this uses a pulse width modulation signal, which is, I guess, it seems a good way to control, to generate servo control signals. The length of time a PWM is on is referred to as the duty cycle. And a duty cycle is measured in percentage. Thus, a duty cycle of 50% means the signal is on 50% of the time. And if it's 75%, it's on 75% of the time, 25, so on and so forth. The variation in the duty cycle is what tells the servo which position to go to in its rotation. Cool. Writing code that sends precise PWM signals to the servo would be time consuming. So we don't have to do that. We require a lot more knowledge about the servo. Since this has got built-in code stuff, I don't necessarily have to worry about that, but we obviously will be taking a good look at the code when it is code time, because the code is really important. And just because we're not writing it doesn't mean that we can just ignore it. Like, we should look at it. We should take some time with the code. That's definitely important stuff. So, right, what do we got here? So it says to use one of the built-in Arduino libraries, all you have to do is include a link to its header file. A header file is a smaller code file that contains definitions for all the functions used in that library. Okay, that makes sense. It's basically is referring to something else. And by adding a link to the header code, you are enabling the code to use the library functions. This tracks. I feel like I understand this so far. In this case, it is hashtag include these kind of brackets. I don't actually know what these are called, but the ones that are pointy brackets, servo.h. So, right. This gives a little bit more information on the servo library, but I'm not necessarily going to go into that. But we got to get the... Yes, please. I would love some print-to-block Electro-Box, and then I don't have to deal with sticky stuff. I think that's a great idea. I'm all for it. That said, this is actually really cool Velcro. This might be the coolest Velcro I've ever seen, because it's like little tiny plastic beads. So as Velcro goes, it's pretty cool Velcro. I might have to get it for cosplay stuff. But yeah, since this, I'm going to switch over now. Get that. Since this has this kind of plug on the end of it, which I'm very familiar with this sort of thing from 3D printing, because this is kind of the sort of thing that you see a lot with 3D printing, that you would just plug into a kind of a port for it. But since this doesn't have that, I need jumpers to basically connect it to the breadboard. Get in there. So we'll connect a white to the white, a red to the red. Come on. Like so. And a black to the black. Eat it. And now we can actually connect it to the red board. So that's much better for us. And we're going to need the potentiometer as well. So let's get that going. Yeah, no, not squiggly braces, not angle brackets. The pointy ones. I can show you. These brackets. Like so. Those brackets, whatever those are called. I'm keen to know because I'm quite curious. All right, so come here, potentiometer, and boop, 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 boop. Come down here. We're gonna pop you into place like so. I do love. It's just so satisfying. Angle brackets. Thank you, Melissa. You're wonderful. All right, so now we have the ground of the servo getting into the rail. We have the power of the servo also into the rail, but the signal is actually going to connect over here to number 9, it looks like. I hope that's number 9. These are always a little bit difficult to see. That looks right. That looks correct. I like squiggly brackets. Squiggly brackets are good. Oh gosh, I'm so pleased to see to see y'all nerding about brackets. This is what we're here for. That's fantastic. So we've got the kind of the servo kind of hooked up. I want to get those cables out of the way. I'm going to need a few more. I want to connect the middle peg, the middle, gosh, I have lost all my words today. I am so sorry. The middle pin to connect to A0. So that one there. And I am realizing that I spoiled myself a little bit with some tiny wires that lead to much cleaner breadboards. And now I want that all the time. I might have to just make myself some special jumpers, because I imagine that's the thing that you can do. You can just get the end bits, get this bit of the jumper, and attach it to a shorter piece of wire, so it's a little less like spaghetti on the breadboard. Because sometimes spaghetti is nice, but sometimes it is a pain in the tuchus, and I prefer it when it's edible. I prefer my spaghetti edible to wire spaghetti. Get it. All right, and then like so. All right, everything is looking pretty hunky-dory. This is a pretty simple setup. We've got our potentiometer connected to power and ground, and sending a analog in signal to A0. We've got the servo connecting what looks to be actually kind of bringing. Oh, I apologize. I missed a couple of jumpers. I was wondering to myself, where is the power actually getting to the breadboard? It is called, I haven't done it yet. So let's fix that. Right. Okay. So it seems as though pin 9 is a PWM pin. Not all pins get PWM signal. So we're learning all sorts of extra stuff. Thank you, Professor. You're lovely. So yeah, we want to hook this into a ground. Yeah, that is, I'm going to try not to get my face in front of the camera. Hello. Yeah, that looks like a, nope, let's go up one. I do feel like sometimes like I need a magnifying glass for this stuff because it is tiny. But it is much harder to film when you're looking at things through a magnifying glass. So there we go. Now we're all connected. Now we're all connected. Let's see here. All right, y'all are. No, Professor, you are just fine. Frankly, I was gonna say, as the only person who can talk, I can actually choose to ignore anything I want. Or actually, it's also possible I'll just miss stuff. You are perfectly okay. I do not mind a little bit of extra information. I don't think anyone else minds either. So I think that I think you're perfectly fine giving a little bit of extra information to myself and to viewers on what we're learning about or what I'm learning about. So I'm not bothered. Hopefully no one else is bothered. Because I am learning. This is new to me. This is not something I'm already an expert on, and having someone else tell me how to do it. That is different, and that does kind of suck. But when you're actually learning about something the first time, it is quite nice. At least I like having a little bit of extra information. I don't know about everyone else. So to each their own. Me, I like a little extra information. So where were we? Yes, we are all kind of connected up here. It looks pretty good. So yes, as I was. God, English is beyond me today. I might have to switch to another language at this rate. I only have like a quarter to a third of another language in my personal dictionary, so this might be difficult. So Servo is, interestingly enough, is connected to the power rails, and as well as the port 9 potentiometer to A0, as well as connecting power and ground to the rails, and then we are providing power and ground via these jumpers here. So yeah, I think we're ready to plug her in. And be ready for it to do something wild, because I seem to recall it did something weird last time when I plugged it in. So brace yourselves. All right, didn't explode. My favorite. Oh, thank you, thank you, Footleg. Thank you very much. I'm so glad that you appreciate the electronics being made accessible. Honestly, I really think it's super important, because I don't know that electronics are always super accessible. They certainly didn't feel always very accessible to me, which is why it took me so long to get into it. Like, I think there's probably a reason why I I know so many things, but this is not one of them. This is something that I have just never touched, because it was scary, because it was weird and terrifying and just so foreign. But not just foreign, but all of the information was so over my head that I often felt like I didn't know where to start, would get frustrated and give up. So I feel like making this stuff accessible is super important, and I really hope that it can help other people like me, or who are young and curious and just want to take those first steps, because that is it. These are the very first steps. There's so many steps after this that I'm actually really excited to take, but this is the first steps. And so thank you. I really appreciate it, because that's exactly what I'm trying to do. So, oh my gosh. Thank you, Joe. Oh my gosh. Joe, if none of y'all, let's not hit lights over. If y'all don't know, Mr. Joe, the 3D printing professor, he also has his own YouTube channel that is fantastic and educational and really, really good. He also is always very well dressed and presented, which I think is underrated in men on YouTube. But as you can see, he's also very, very smart. He knows his stuff. So if you aren't already following him and subscribed, you definitely should, because he's great. He's fantastic. And he's obviously a mention in my book. So thank you, Joe. That is fantastic. Right. My gosh. So now that I've had a lovely diatribe. Is it a diatribe if it's good? I feel like it's a diatribe if it's negative, but somebody with an English degree can correct me here. I'm just an artist. I don't know things. It is time though. It is time. Let's switch to the code. What do we got here? So I'm not personally attacking anyone with the well-dressed comment. I mean, y'all, I'm wearing a friggin' Star Wars tank top because it is warm and I like Star Wars. So I'm not exactly the shining example of well-dressed all the time. I am sometimes. I do really like being well-dressed for streams. And if you go back and watch some of my 3D printing streams, you'll see that I am actually exceptionally well-dressed. But I'm flexible. I go both ways. I go multiple directions, all right? I'm omnidirectional. Anyway, code. What do we got here? We got some code. We've got our servo code. So we've got, exactly like I mentioned, we've got the hashtag include servo.h. We've got the pot position. This variable will store the position of the potentiometer. Cool. And then servo position. Servo will move to this position. So create a servo object. I love that. Servo, my servo. Void setup. So obviously we've got to get going. And then we're attaching it to pin 9. So that looks good. And then we got to just, honestly, this is short. This is nice and easy to understand. It's going to read the position of the potentiometer through the A0. It's going to then map that position according, so convert the potentiometer number to a servo position from 20 to 160. Cool. I do like this note. It's best to avoid driving the little SparkFun Inventor Kit servos all the way to 0 or 180 degrees, as it can cause the motor to jitter, which is bad for the servo. So now I know. Thank you, because I totally would have been like all over the place. Move the servo to the 10-degree position. All right, let's send it. Let's see what happened. Upload. It is thinking. It is considering things. What do we got? Are we up? Oh, there was an error. Oh, I didn't set the we got to set the COM port. That's important, and I forgot that. So I believe the appropriate response is womp womp. And we're going to try it again. There we go. That looked much better. Oh! Y'all see that? Let's switch over. We got to get back. Oh, hold on. All right. All right, let's switch back up here. Yeah. Switch to the servo cam. You got it. We're just gonna kind of do that, and then we're gonna make sure that we're still in focus. This is the one downside well, it's not really a downside, but it's one of the things about macro lenses like this, which actually you can't even see. It's not even in the shot. It's up here. You can see my finger, but that's it. Manual focus. Autofocus is hot, wet garbage fire on most macro lenses. So with manual focus, and I gotta switch it over. So let's see. Yee! Oh, he's trying so hard. I can just kind of tell. It's like, oh, it's very small. It tried very hard, but it's not very powerful. But, I mean, that is success. That is definitely success. In fact, I can totally pull it off the Yay! I love it. I'm into it. Let's reattach you, my little friend, to your weird Velcro. So, this is good. We are cooking with gas, as they say. Yeah, this is definitely success. Now, I've actually already, like in the code of note, I've already paid attention. But I'm curious about the coding challenges that reverse the servo direction. Try making the servo move in the opposite direction of the potentiometer. Ooh, I have no idea. I'm not actually sure. Let's go back. Let's take a look. Okay. So it reads that, and then it maps it. So, okay. I bet you, if I switch these, that it might go in the opposite direction. So let's real quick. Am I still skipping frames? Out of curiosity, just because Streamlabs is giving me some errors, I just want to check if the video is okay, if the stream quality is okay, because I've never had that come up before, but I want to just make sure everything's okay. So yeah. I was gonna say, just to respond to the chat, I was gonna say I'm pretty certain that the Mensch was pegged as German. It's actually Yiddish. I mean, it might exist in German as well, because Yiddish is based on German. Yiddish is basically an amalgam of German and Hebrew, if I'm not mistaken. But I'm Jewish, so I know some Yiddish, and I use it liberally. Yes, video's good. Everything seems fine. Thank you, everyone. I'm just gonna ignore Streamlabs then when it's telling me that the things are going sideways. But yes, before I switch it, let's check real quick so at the moment, if I rotate the potentiometer to the left, the servo rotates in the opposite direction of the potentiometer. I think, admittedly, I have the potentiometer probably flipped. Oh, yeah, I have no idea. I don't actually speak German, so I don't know what I said. Let's switch back now to the Arduino. Yeah. So I flipped these numbers. I flipped these numbers now, and yeah, let's see what happens, because there's only one way to find out. There's only one way to find out. We'll go back to the thing. I will upload it. Da, 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 da. Bob's your uncle. I just love how this thing occasionally just does stuff, which to me is very much kind of like, it's just a little, you know, ghost in the machine. So now they go together. So I reversed it. I reversed the servo direction because now they correspond and they were opposite before. Huh? Yeah. Awesome. That's awesome. Fantastic. Change the range is another challenge. Try altering the map function so that moving the potentiometer a lot only moves the servo a little, or vice versa. Now, it already feels like it doesn't move the servo a whole lot when I move the potentiometer. So I feel like making it move less would be boring. So I feel like it would be better to make it move more. So maybe let's see if I can do that. I hope I get to use mensch liberally as well, Rob. I think that I would be very happy. Very happy if my life and the chat were full of mensches, if everyone's just a mensch. That would be great. Did I come up with a simpler solution for changing the direction of the servo? Admittedly, I do think that sometimes because I am not familiar with this stuff, that the solutions that I come up with are also not standard ones. Also, I do approach things differently. I got weird brain. It's not quite square brain or smooth brain, but it's weird. So I sometimes approach things differently. I would have minused it from the max of the range. Yeah, map reverse thing seems easier. So I'm gonna go back again. And take a look at this. So, all right, so if, altering the map function so that it moves the servo. I feel like, I feel like maybe if I reduce this, it will move it more. Curious. What y'all think? Never being set by the plot and subtracted it from the max number that could come in. Yeah, see, I'm approaching things very simply. And so I'm kind of like, altering the map function. Yeah, I'm not entirely certain because I realized that if I just lower this number, say I half it, then it will just only read a smaller range in the potentiometer, which isn't quite what I'm looking for. I feel like there needs to be some sort of maths involved here to effectively, I suppose, translate it differently. And I'm kind of also sat here going, how much time do I want to spend on this? Because we still have 2 more bits to go. So maybe this will be one for me to figure out later. Another suggestion for the challenge is actually, yeah, see, what Melissa said is exactly what I was thinking, that, you know, decreasing the range of the potentiometer will only increase the speed of the servo to a point, and then there'll be a dead zone, and that's boring. Change the inputs to the map function. Oh, I see. Oh, apparently kitties like my voice. That's great. So if the, all right, I was going to skip this, but now y'all got me really curious. All right, so if the first two numbers are the input and the last numbers are the output, I'm assuming that means I can put more numbers in, maybe? Okay. I'm still kind of sat here going, if, all right, so I like it facing the same direction. So I guess, I mean, I can change this up to 180 and 0, but again, it says that it's bad for the servo, so I don't want to hurt the servo. I don't want to hurt the tiny servo. Tiny servo is my friend. Change the output numbers. But won't that hurt the servo if I change them? All right, I'm gonna. Whoop. I'm gonna do that, and we'll see how that goes. All right. I mean, that does definitely give a little bit more, but not I guess to be fair, there is a limit to this because, all right, I was gonna say, to be fair, I'm not really noticing much of a jitter, but I had an idea. I did have an idea. I have a thing I want to try. So I had a thought. Lasers are great too. Lasers are another thing I'd love to learn about. So I'm going to change this. I'm going to make the range super small, because I want to see what happens. This is what we do. This is what we do. We just write things into the code to see what happens. Oh, oh, oh! I forgot to switch it. Sorry, guys. It's much faster now. That's great. That's very satisfying. But obviously, if I go past that, it will just stop. But I actually think that this was what I was supposed to do all along, which was exactly what I thought to do, but also thought was wrong. Yay! No, I don't want to make the Servo sing a song of jittery death. Servo is my friend. I don't have a replacement. All right. I was gonna say hello to people who are still dropping in. Obviously, like I realize that not everyone is able to come in from the beginning, but I am please. All right. I think at this point we can move on. I think it's time to go to the next thing. So, I was gonna say, I was gonna say for our new friends, for our new viewers, aka hello the beard X16. what a name to say out loud. I don't have super chat, unfortunately, because it is something that is reserved for channels above a certain amount. So instead of the super chat, I have the Ko-fi. Set up. So if you donate to my Ko-fi, it will pop up on the screen like a super chat, and that is admittedly much better because it means that YouTube don't take something like 20% or whatever it is that they take. I get to, it all goes to me instead. So in a way, it's much better than the super chat. It's just a little less simple and straightforward. One of these days, I'll figure out a way to work it into YouTube, because I don't know. It's gonna say this feels like one of those things that sounds insanely difficult, but also probably something I could maybe figure out with enough time. So the next thing. What do we got? Yeah, don't drive your friends to distraction unless they have extras, because then I wouldn't mind. Like when you've got extra stuff, then testing things to the point of breaking them is very interesting, and you can learn a lot from them. But I only have one servo, so I'm not gonna break my servo today. But hi, I'm back on the big screen. So next, not only do I get to bring in this little friendo for the next bit, but I also get to use the RGB LED, which is basically my favorite LED because it is all the colors. Now we're gonna disconnect the thing because I have a tendency to forget that. Yeah. But obviously we've got now our ultrasonic distance sensor. I've never used one of these before, so I am totally going to read this out loud because this is new. Distance sensors work by sending pulses of light or sound out from a transmitter, then timing how long it takes for the signals to bounce off an object and return to a receiver, just like sonar. Holy crap! That's awesome! Some sensors use infrared light, some use lasers, some, like this friendo, use ultrasonic sound. Sounds so high-pitched that you can't hear it. Are my cats gonna be able to hear this? Is this gonna piss off my cats? Oh. All right, y'all. If be prepared. We might have angry cats just racing in here at any second. So, hopefully not. But it is, again, this is so cool. And admittedly, I am I'm not sure how close I can actually get this where there'll still be enough light on it. Oh God, this is a fun experiment. Look at that. Just because I can. Look. HCSR04. We've got the different pins kind of marked here. And yeah, I'm sorry, I can't get over this. Also, the color of this PCB that this is on is amazing, and I need it. And I'm somewhat frustrated that it is not so easy, apparently, to get PCBs in those colors. I would know, because I tried recently. And if you're curious what the heck I'm on about, you better be subscribed, because there's going to be a new video dropping very, very soon, also about electronics and some of my adventures with Raspberry Pi. So if you're here, it's because you like electronics. So you definitely are going to want to see this one. But yeah, so when working with electronics, datasheets are your best friend, it says. Datasheets contain all the relevant information needed for a part. In this circuit, we are calculating distance based on the time it takes sound waves to be transmitted, bounce off an object, and then be received. But how can we tell distance from that information? The answer lies in the datasheet for the distance sensor. In it, you can find the equation for the program needs to interpret the distance. That's very, very cool. I am not actually going to pull that up right now, but I will definitely be taking a look at it later. See, I am very bad about the whole like and subscribe. Smash that like button and all that, because it's odd to me. But you know, maybe I'm just being too British about it. So, you know, please, let's not tap the mic. If you'd be ever so kind to please smash that like button, I would be ever so grateful. And that is, I think, the most English accent you'll ever get out of me, ever. I hope y'all appreciated that, because I'm never doing it again. That's it. That's the end of the stream. That's it. I'm done. So this is also, I realize I'm bouncing back and forth a lot, and I apologize. But if you haven't figured that out by now, then I suppose you haven't been paying attention. Yes, this is also going to be using if-else statements to run one set of code when a logic statement is true, and another if it's false. Which I think we've done some. I think we've done some if-else, or maybe I'm thinking of things I've done elsewhere. But I definitely have seen the if-else stuff before. So let's get hooked up. All right, let's. All right, so this one doesn't actually use the servo friend. So we're going to disconnect all of that and move servo to the side. Oh, thank you, David. Thank you so much. I am so grateful. I was going to say, this is very, very, very helpful. In case you all don't know, I am an independent maker. I very much rely on sponsorships and donations and my patrons and stuff like that. Y'all are what make this happen, what makes this possible. So thank you. Thank you, David. Thank you, David. You're awesome. 2 massive thumbs up from this this nerd. And yes, I was gonna say, there are many of my, I think, beloved patrons in the audience today. So you guys know I love you. And also, just gonna say, for those of you who perhaps haven't seen all of my shenanigans and stuff, I actually use they, them pronouns. But it's okay if you mess it up. I understand these things happen. And long as you try, that's all that really matters to me. So yes. Where were we? I got distracted by all the things. All right. I am actually I'm going to pull many of these out because, oh no. There we go. Sorry about that. Got a whole shock of hair in there. So I'm going to leave the ground and the power connected because I'm going to need those. And we're going to take the distance sensor. Thank you, the beard. Thank you so much. You guys, y'all are really on it tonight. Thank you so much. I really appreciate it. You guys are just killing it. So let's see here. We need this one to go. We need the VCC to go in the 3. And it is in the A. So, ooh, that's a tight fit. But we're in. We're good. I actually quite like when the breadboards have a bit of a tight fit. I always get a little worried when they're loose. I hope to save people blowing up their own sensors. Absolutely. So we're going to need quite a few things here. Oh, this is unfair. This shows a purple jumper, and I don't have a purple jumper. That makes me sad. I want a purple jumper. All right. Let's get up power. So it looks like we want to connect, I guess the VCC is the power, because that is what that's what I'm kind of seeing here. It looks like E3, yeah. Just wanted to double check that one. So there we go. We got power. I'm actually realizing that I don't even have, oh no, I do have purple jumpers. And I was gonna say, these are my my pie jumpers, which are there. These ones are, actually, to be fair, they would probably work. But they've got purple and orange. I require everything in rainbow. I definitely, if I can have a thing in rainbow, basically, that is the best. So we then connect the the trigger pulse input. Oh, yeah, I guess VCC is power. I didn't notice that we got, I was gonna say, if I can show you. Yeah, there's a little thing here that I totally missed. Yeah, so we want to connect this one all the way over here to, it looks like 11. Yep. Which is 4 up. Yep. And then the echo pulse output, which is the next one, will go into 12, like so. And then ground to ground. That's pretty straightforward. Yeah. All nice and snug and cozy. What do we got now? Now we've got the LED, which we want the flat side on this side, and we're going to put it, I got 22 to 25. Come on. I always struggle with this one a little bit. There we go. There we go. And we're going to need some resistors because resistors are important. And when it comes to LEDs, so we're using some 330 resistors. You know what, actually, I'm being silly because I have some pre-bent ones because I don't throw anything away. I hold on to every little thing. So of course I have saved my resistors from the previous projects, and I'm gonna go. Eat it. They're so tall. They're really long. So as I mentioned earlier, I have been working on a very exciting. Am I using the right ones? Yes, I am. I've been working on a very exciting electronics project of my own, and it obviously involved some breadboarding, and I found that I was very bothered by having things be messy. So I very much, in fact, I've got the mostly emptied out breadboard here. You can kind of see I went and made it all very, very tidy, but same thing with the resistors. I kind of made them fit a bit nicer, and this is the artist in me that dictates I must do things this way. Oh, I see. Thank you, Dr. Footleg, for the extra bit of information. I will read it. Apparently, usually the ultrasonic sensors are 5-volt logic, so it's fine in an Arduino, but you have to use a resistor divider to drop the output logic voltage to 3.3 volts if you're using one with a Raspberry Pi. Now, my question, right back to you, is that true of all Raspberry Pis? Because I feel like the higher level Raspberry Pis, like a Raspberry Pi 4, would probably be okay with it, but I'm not sure. So let me know, because I'm curious. Also, I need another ground. Oh no, don't run away. So I need, because I know once I get that third resistor in, I'm not going to be able to reach at all. So, whoop. And now, the third and final resistor, like so. Okay, that is good. Now I have to connect the signals for the LED, because obviously our LED has to be able to talk to the breadboard. So I'm trying to figure out a good angle for y'all, because it's interesting. So what does it say? All Raspberry Pis are 3.3 volt logic. Good to know. Thank you so much. That is useful information. I love learning about this stuff. So what do we got here? We are connecting the LEDs. So what do we got here? It looks like 3 Yep. And it looks like it's skipping 4. Yes, because I don't know if y'all can see here. As the professor was saying earlier, not all of these are the PWM. So you can actually see here that it looks like the PWMs are listed with the squiggly line. I think that's called a tilde. And I'm not sure if you guys can see. I think you can. That 4 does not have it, but 3, 5, and 6 do. So we're gonna put it in. We're gonna skip 4. Yep. And there we go. Okay, how are we doing here? We got power and ground. Check. We've got resistors for the LED. Check. We've got the ground for the LED, and we've got the 3 different signals going in. Check. Got ground and power for the ultrasonic distance sensor. Check. And we've got the 2 signals. Now, interestingly enough, the 12 is not basically the echo pulse output is not one with the pulse modulation. So, but I'm following instructions. I'm doing what I'm told. I'm also going to have a drink real quick because I'm thirsty. How do other streamers do that? How do other streamers manage talking for hours and having to lubricate their vocal cords? Is there a way? Is there a nice way to do that? I don't know. But the Explorer Hat Pro Board. Oh. That's very good advice. I like that the Explorer Hat Pro Board from Pimoroni, which is basically my favorite local electronics company. Shout out to Pimoroni being just excellent all of the time. For getting started with breadboarding. The 5-volt safe inputs. It has 5-volt safe inputs as well as motor drivers and some built-in LEDs. That's cool. I definitely have to check that out because that sounds like it would be fun for exploring. So far, all the stuff I've done for the Pi has been very much like I'm doing this thing as a means to an end. I'm looking for this result, and so I'm going to do this thing. But that is very good to know. Thank you. That is useful. What do we got? All right, so I think we are connected. So now we gotta get the code. So let's switch on over to the code. All right, as y'all know, I like to have a good look at things a little bit before getting going. I like to familiarize myself with the code. Since I'm not writing the code, I don't necessarily gain the familiarity through typing it out. So I definitely like to make sure that I kind of go through it. And I'd say that if you are also learning this stuff for the first time, that it's a good idea to kind of get familiar with the code any way you can, whatever works for you, because not everyone works the same way. So I've got here, obviously, we have got, so we're going to control the color of an LED using the distance sensor. That's cool. I'm into that. So we've got 11 and 12 for the sensor, 3, 5, and 6. Yep, this all looks good. So this will store the distance measured by the sensor. Cool. We'll get started. Set up the serial connection with the computer. Yep. Then the trigger pin will output pulses of electricity, and the echo pin will measure the duration of pulses coming back from the distance sensor. Whoa! All right, yeah, this is cool. Obviously, so now we get into how it determines the color, which it is looking at if the distance is less than 10, it's going to be red. If it is between 10 and 20, it's going to be yellow. And if it is further away, it's going to be green. So we got a traffic light system as opposed to a rainbow. I guess I can deal with that for now until I have a chance to make it a rainbow. We've got a little bit more information down here. We got the variable to store the time it takes for a ping to bounce off an object, and variable to store the distance calculated from the echo time. So this is cool, but also probably less important in the grand scheme of things. So let's plug in. We are on. We are ready. Let's upload. All right. So, all right. We've got, interesting. I think it's actually, it is, I think it's sensing maybe the computer or the book. Also, I'm not sure how well you can actually see the LED. Let's turn this off for the moment so you guys can see the color a little bit better, I hope. Maybe. I think that's, you can tell that that's red. But let's see what we got here. All right, so I think it was reading the book. So good night, Ruth. Thank you so much for coming and joining us. Please, everyone, wish Ruth a good night and thank her for coming and showing up and helping mod, because she is just the best and also very much worth your following. But okay, so we can see now that it's green. I had to move the book. Ooh. Oh. It's going yellow. Oh, red. Red. Admittedly, the distance on this is impressive because I actually, it's fine that the distance sensor is not. I see. Line 23 on the RGB LED appears to not have a resistor connected. No, it does. It does. It's here. I think it just looks funny. The angle is probably a bit funny, but yeah, it definitely does. Don't worry. Don't worry. There's resistors on everything. It's all good. But yeah, it is interesting how far this distance is, because if I pull my hand like way over here, I'm way over here, like basically as far as I can go. I have to get my hand basically this far to make it be green. If I come in, this is actually where it starts to go red, which is not far. Wow. So, okay. So the distance is actually pretty substantial. That's cool. So okay. So this is running the else if statement. I'm going to leave this light off for the moment so that you can see the LED. Yeah. No, I've got the three colors, so it's definitely wired correctly. But if, so we have the logic statement, and in this case, the logic statement. So yeah, but this is if I'm a certain distance, I get this color. If I'm a certain distance, I get that color. We have done this stuff with the previous projects, I am pretty certain. But yeah, so that's fantastic. So for the coding challenges, I can change the limits of the distance sensor. So yeah, actually, let's do that, because it's actually really surprisingly far. So if the distance is less than, let's reduce this massively, because the distance is actually huge. So if the distance is less than 2, if the distance then we'll have red. If the distance is between 2 and 5, and then if else, yeah. So let's try that. Let's try that. Let's upload that. And see how that goes. Because, so, oh, yep, now it's much closer. That's how close I have to get now to make it red. Cool. And yeah, this is basically, it's green with my hand here. You can kind of, in fact, actually, let's see if I can't let y'all see a little bit better what my hands are doing. What up? Sorry, you guys lose space for a second. So yeah, this is yellow. This is red. So yeah, it's a lot closer. Before it was like I was all the way over here before it changed, which is crazy. Come on, tripod. You can do it. I believe in you. There we go. Actually, let's go back up a little bit more. Yeah. Cool. So, success. We changed the distance. Oh, I can change the unit of measurement. What? Oh, wow. Oh, wow. So our lovely resident SparkFun expert, Mr. Rob Reynolds, has shared that the range on the sensor is 2 centimeters to 4 meters, which is basically this whole room. This room, actually, the length of this room is 4 meters, just over 4 meters. So that's amazing, actually. I'm super, super impressed. All right, what distance values is it printing out in the serial monitor? That's a great question. How do I open up the serial monitor again? Serial monitor. It doesn't seem to want to let me see it. Very interesting. Yeah, I'm assuming the distances are centimeters at the moment, but yeah, weirdly enough, I can't seem to yeah, it's definitely got the serial print in here. Sorry, I thought I'd switched over. Yeah. So it's definitely got the serial print in here, but it doesn't seem to be printing to the monitor because, yeah, it just doesn't. Maybe it's the plotter? No, doesn't like that either. Oh, well. I am suddenly, I am, of course, in that way that this is me. I'm like, oh, it does, yeah, it does suggest to add a 4th color. Knowing me, I would want all the colors though. And I have done that actually before. I did do that with the, basically one of the first projects in my own time. I don't know if I saved it though, is the only thing. I'm not sure I actually saved, my version with the full color. Possibly here. No, this isn't, yeah, this isn't my version. Yeah, I may not have saved it, but I actually went to a not insignificant amount of effort to figure out how to make it so that you can get a full range of colors, which was very exciting. But is the baud rate matched? Ooh, maybe not. Where do I find that? So this is, it looks like 9600. I'm not sure where I, this is where it's like, oh, Yep. Oh, this is already outside of maybe some preferences. Oh, not sure. I am not sure. Oh well. I am not too concerned. Not too worried about it. Because, yeah, I am not actually sure where I find the baud rate. Yeah. This is very much where my own knowledge kind of ends. If you open the serial monitor, it'll be in the bottom right corner. The only problem, though, is that the serial monitor, it won't actually let me look at it at all. It just is, yeah, it just doesn't work. It's like an empty page. Very weird. This is probably a thing to figure out another time, because there is still another project to do. So we still got to do the motion alarm. So let's do the motion alarm. Let's turn this off. There we go. And boop. We can turn the light back on now. Yeah, let there be light. So what do we have here? We have, so for the third project, for the last of the three, this is the one that I didn't necessarily prepare for. So a motion alarm, which is very cool. So the circuit gets really fun when you start to use your servo to animate the world around you. To do this, you'll need to connect your servo to some physical mechanisms. Tape and hot glue are easy ways to connect things to your servo. You can also loop a paper clip through the small holes in the servo arm to serve as a linkage. I missed this. I may have missed this when I was looking ahead. If you've opted for the extra materials, use the following instructions to create a moving pop-up for your motion alarm. I did not do that. Yeah, now I'm potentially having I'm probably having an issue with the monitor because of OBS. I'm not going to stress about it too much. This is a later problem, basically. But my current problem is that I didn't make an angry cat in advance. And so I'm kind of like, I imagine that this will work just fine without it. It will just be a little less exciting, and for that I am sorry. What do we got? Yeah, basically it has it where you basically attach a, excuse me. I'm just banging my appendages on everything. But yeah, it has attaching a piece of paper via a paper clip to the servo so that the servo can move and wiggle the paper, which is really cool. But I imagine that we can probably accomplish the same thing without it. Like we can still make it work. It'll just be a little less exciting. But we've got some more hookups to do. Actually, it looks like many of this is just the same, which is convenient. Let's move that down. But we got to add the servo back in. Yep. And we have to add what looks like a buzzer. We got to add our little friend, the piezo buzzer, back. Y'all remember this, right? Those of you who were here before, our little friend, the buzzer. We played Simon Says. It was fun. It was enjoyable. So we need to put this, we got 14 to 16. Oh, my goodness. This one is always a little, oh wait, I forgot. This one does have a polarity. So we need plus in 14 and minus in 16. I am glad I thought to check because I'm pretty certain I had it backwards. Boop, boop. That's a bit better now. Now, see, this is where like we have like all of the jumper cables now, and it starts to get a wee bit confusing. So you want to connect on 14 to 10. And then we want a ground, another ground. Connecting a ground to 16 and to the rail, like so. Then we've got our LED set up already. We've got our sensor set up. So now we just got to connect the servo back up. So scrunch. And we got white will go to 9. Our signal for the servo. And then we'll come up here, connect our servo to the rails so I can get some power and ground. All right. How are we looking? We're looking all right. Let's move the servo up a little bit. You did it. Okay. We got servo. We got LED. We've got buzzer. We've got sensor. This is gonna be interesting. This is gonna be exciting. So I see. I think I understand what we're doing here. But thank you so much for joining, Melissa. Bye. I feel like I always feel like a stream is a little bit like the kind of get-togethers I throw where people are encouraged to show up when they want and leave when they want. It's very casual. What do we got? So let's open up the code for this one. Motion alarm. New. And let's have a look. Righto. Code time. We've got our servo. We've brought in our servo library, which is again very important. We've got distance sensor. We've got LED. We've got buzzer on 10. We've got the distance floater, which I realize when I talk about this, I make it all sound a lot less serious, and I apologize to programmers and coders everywhere for that. But we obviously, this is again going on 9600, which I'm not gonna worry about. We got our distance sensor being triggered and everything kind of getting set up. And then, it looks like this is inches instead of centimeters because Americans made this. That makes sense. I don't know that I paid attention to that in the last one. So again, if the distance is less than 10 inches, which is again, super close. So I might change this off the bat if I'm being honest. Let's say if the distance is 2 inches, it'll be red and the servo will wiggle and the buzzer will buzz. That sounds good. If the distance is between, we'll say 2 and 6, we'll make it a little further this time. Then it'll be yellow. And then if it's far away, it'll be green. So very similar to the last one, but we've now added in the servo. So it's now obviously, and the buzzer. So instead of it just taking the information and giving us a color, it's going to give us a color. It's also going to give us a buzz. It's also going to give us a servo, which is all, thankfully, like looking at the code, it's not that complicated to have this stuff in because you just have additional stuff under the if else. So that seems pretty good to me. Let's plug this baby in and get her going. Oh, yeah. I was too close, and the book is too close. So let's move the book. Let's turn off the light again, so we can see. So everything is well. All is well in the house. There is no intruders. But let's go down again. If I start to get closer. Oh, it's yellow now. Yep, green, yellow. That I think that worked. Admittedly, again, the distance is quite close now. So let's actually, real quick, I'm gonna change it. I'm gonna make it the distance 3 and 3 to 6 because I think I made it a little too close. All right. Oh, yep, we're back to life. Oh, yellow alert, yellow alert. Hey! Oh, I'm such a child. I love it. This is so much fun. This is so enjoyable. Yeah, I see. I am with you. I'm with you on this, Rob. Starting to combine the things together to make them work together is actually really exciting. And it's nice to see that it's not insurmountable, because I think sometimes it can feel a little bit like adding more things is going to make things more complicated and it's going to make things harder. But like, this was okay. And even the scary bit, the code is not, it's not impossible to digest. Like it's laid out in such a way that is understandable, and like I feel like I can understand how I'm getting from point A to point B. I'm gonna move this over a little bit because this is just. That's just great. That's so fantastic. And like, of course, someone like me, I am already looking at this and thinking about all the things that I can do with something like this, which is effectively a motion detector. Like, yeah, like it is a basic motion detector, but it's a motion detector all the same. And it is 100% the sort of thing that it's like, okay, so with something like this, motion detector, LED, servo, maybe instead of a buzzer, it's connected to something that would, I don't know, trigger a voice line or something through a speaker. Because this is actually, hilariously enough, this is perfect training for a idea for a future project I have that may or may not involve our favorite yellow triangle friend with a single eyeball being triggered by a motion sensor to open his eye and scare the ever-living crap out of anyone who walks in the room. This is my idea of fun, clearly. So I'm not mean. I'm just a big fan of Gravity Falls. I feel like that's it. So I love being able to see how the creation of this is not absurd. It's not insurmountable. That is friggin' fantastic. So I want to actually look to see what other coding challenges are in here, because like, yeah, so obviously, so I can change the servo behavior, it says. Yeah, triggering music, or triggering, again, like a voice line, because that's what I want. Like, I'm not gonna lie, I had one of those late night, like, brain explosion kind of moments a while back, when I had just basically the thought of creating a wall-mounted bill cipher that basically just chills there until someone walks in the room, in which case then he would open his eye and say something bill ciphery. And I love that, because it is both simple and straightforward, but also for me, at the time especially, completely had no idea how I would do it. Now, I feel like not impossible. So, curious to see about changing the behavior. Okay. So I can actually, if I switch over, I think I know how to change the behavior. I can basically, I'm curious how 150 translates to 135 degrees, but what happens when I say 200 with a delay of 200? That's that will definitely change the behavior, which is interesting. Let's see what we got now. Definitely a different behavior. It's a much slower, or rather, like, there's more of a gap between the movements, and they are a little bit bigger as well, yeah. And yeah, I mean, Bill Cipher would be a great Halloween project, I think, because he's scary. See, this is fantastic, and I could also make it super short, which, if I break the servo, I'm gonna be sad. But let's see if now it's fast, super fast. What else we got? I can change the alarm settings. Try altering the code so the alarm goes off for much farther, closer distances. Done that. That's tick. I've changed the distance. Add a second mechanism. Try your hand at making different objects move with your servo motor. Don't have a cat. Make an interactive pop-up story, room alarm, treat dispenser, automatic fish feeder. Hey! I was going to say, y'all were talking about feeding axolotls. There you go. Fish feeder. That is, I mean, I don't have fish. So I can't make a fish feeder, nor, I think, am I prepared to make a fish feeder right now. But I love that this is, I'm curious how big the number with the servo can go before it isn't happy. I don't know if it's actually able to go that far. But I don't need a cat feeder. I was gonna say, it's been suggested that I can make a cat feeder, but I actually don't need a cat feeder because my cats are great. They actually self-regulate. I don't have to feed them at certain times. So I suppose this means I wouldn't have to feed them at all. I like this idea now. Automate everything. Servos and everything. But let's turn this back to 100. Oh, not 1,000. That would be, actually, yeah, let's make it very slow. Just for the lulz. Let's make it more slow. Oop. Yeah, see? Now it's quite slow. But actually, is the buzzing also slower? It is. Interesting. I hadn't noticed that the buzzer and the servo are actually tied together. So when the servo goes slower, the buzzer goes slower. When the servo goes faster, the buzzer goes faster. I would have to separate them out, presumably. Maybe? Yeah. Interesting. Oh. Ah, all right. I can definitely see more ways I could mess with this to make it different. But it works. It works. This is fantastic. It is. That's it. It is 100%. This is project 3 complete. And that is just, I don't know. I think this is super cool. This doesn't, in some ways, this doesn't feel like a big thing, but at the same time, it feels like a huge thing. And some of that is just going to be due to the fact that it's my first time. First time with a servo, first time with an ultrasonic sensor. This is just like another chapter kind of complete in the book of electronics for me. And that is amazing. The number for the analog right is a fraction of 255. Okay, that's good to know. This is very much, I do very much enjoy the people in the chat who do know more and share their thoughts and stuff like that. That is definitely very good. But yes, I will absolutely be learning more about servos for controlling eyes in the future. But that is future because I have other things to finish and to work on first. But yes, as it has been said, this absolutely opens up possibilities, and they're awesome possibilities if you ask me. I will obviously still have more to learn on the code front, but now that I've got a basic understanding of kind of how these sorts of circuits are built code-wise, that means that, yeah, there's room for more. And that is actually, that's project 3. Project 3 is done. Oh, I got too close. That's my warning. Looking ahead a little bit, it does look like it is just continuing to go up from here, which is both exciting and scary because project 4 clearly has a tiny screen. Tiny screen. Oh. Tiny screens admittedly should not scare me because I have been doing some larger screen stuff. But again, it's different. And that is admittedly something that I find very interesting. Doesn't want me to move it. Is the fact that this is Arduino. And Arduino is obviously one style, as the lovely Joe 3D printing professor was teaching me recently. The code used in an Arduino project is not going to be the same as what's used on, say, Raspberry Pi, because I didn't actually realize at first that they weren't the same. And now I do. Now I can definitely see. Like, I knew that I figured that they were different because they did seem different, but I didn't necessarily know in what ways they were different. I kind of assumed a little bit that they might be the same code, just look different. Of course, now I know that this is Arduino CC, I believe is what it's called. And what I have been using with the Raspberry Pi is Python. And so I am consistently intrigued with how these things can be so similar and yet so different, how they can speak different languages, how they can basically produce the same thing in different ways or produce different things in the same way. And it is really, really fascinating. I definitely feel like I'm starting to understand that, or how people get into this. It very much feels a bit like the possibilities are quite endless. So I am very much looking forward to the next project. I think it's going to be fantastic to be able to add on knowledge of LCDs and stuff like that. And yeah, I know that we're working towards a fully fledged robot friend, and that's gonna be freaking awesome. Because like I can look in the box, right, and I can see we got motors, we got some wheels, we got a battery pack, and we've got a tiny motor driver even in here, which this is all gonna come together to do an awesome thing. I just know it. So if you are learning along with me and you don't have one of these and you want to try it, I definitely highly recommend it. And if you do the first 3 projects and save the 4th, then you can do it along with me next time. But obviously you don't gotta, because lots of people here are just hanging out. But yeah, are there any questions? I realize that it's hard to ask questions with the delay, but I figure it doesn't hurt to put it out there all the same. You never know. Because yeah, I definitely feel like I learned a lot today, and I'm just kind of like soaking up some of that knowledge, but it's very nice. It's very juicy. But like I said before, in case you missed it, thank you, Rob. I was gonna say, I very much appreciate the encouragement. I appreciate the support. I am very grateful to SparkFun for making these streams possible, for making this education possible, because it wouldn't have been possible without SparkFun. So like a huge thanks to SparkFun for being a huge dominant force, it seems, in the DIY electronics, I hate to say industry sounds so cold, community, and creating some really cool stuff and making it all open source and all of that stuff. I'm sorry. Unfortunately, it seems that cats are off elsewhere tonight. No cats. I'm afraid you're just gonna have to come back next time and see if there's cats. That's it. That's all. The only way to do it. I'm just gonna keep coming back until there's cats. But yeah, this is brilliant. Oh my gosh, you guys are fantastic tonight. Thank you, John. Thank you. Gosh, you guys are just wonderful. I really, really do appreciate it. It is very, very, it's a very good feeling to feel like you are doing the right thing. And I feel like putting this out there is very much doing the right thing. I very much hope that others will learn from this too, because I definitely feel like if you don't know and you're afraid to try, this will be helpful. I hope. But like I was saying before, if you are not subscribed, if you are not following me on the social media, you very much should be, because very cool and interesting things are definitely going to be dropping next week. My patrons already know what I'm talking about, because they get the first look at all of my stuff. Patrons get to see stuff first. They get to see behind the scenes that nobody else gets to see. There are obviously bigger rewards at higher levels and stuff like that. So they know what I'm talking about. But everyone else, it is finally time. It is finally time. And I'm so excited to get to share more electronics-based stuff. But again, instead of Arduino, this time it's going to be Raspberry Pi. So I hope that you stay tuned and keep your eyes peeled for that, because it's going to be like in the next few days, provided I can finish the video editing in time. But y'all are fantastic, wonderful, lovely, sweet, and kind. The menschiest of menches audience. I am very grateful. And I am already looking forward to next time. And so I hope to see you all then. Keep your eyes to the skies for the date of the next stream. But until next time, y'all know, keep creating. I'll see y'all real soon.